Right, to move on to addition of matrices. Change my marker to blue. Addition of matrices. Addition of matrices. So now we'll learn how to add matrices. Right. How do we add matrices? Two matrices can be added if they are of the same order. Right. So we should keep this in mind. If they are of the same order. Right. Thus we can add 2 by 2 matrix to another 2 by 2 matrix. To add 2 or more matrices, simply add corresponding. So simply add corresponding elements. This gives matrix of the same order. Right. So let's look at these things that I've underlined. The first one is they should be of the same order. What this means is, so what same order? If we have matrix A and then another matrix B, and then we want to add A and B, A and B can only be added if A and B have same orders, have the same order. Order, if you try to remember, refers to the dimensions, the row and the column. So if A is a 2 by 2 matrix, then B should be a 2 by 2 matrix in order for you to add. If A is a 2 by 3 matrix and then B is a 2 by 2 matrix, we cannot add. A and A plus B cannot add them. It will be like adding, they'll just not add. It will be like adding and mixing oil and water. They are two different things. You cannot add them. So they will remain as this, right? So if we want to add, we have to make sure they are the same. Until then, we cannot add. Perfect. That is it for same order. So we ensure that they are in the same order. To add two matrices, simply add the corresponding element. So if A has A element A, B, C, D, and then B has elements E, F, G, H, then A plus B will be just gotten by adding the corresponding elements. So A plus B will become A plus E. So A plus E. That's for this side. Then this we could add the corresponding B plus F. We add the corresponding G plus G. We add the corresponding D plus H. Very simple. It's just a simple algorithm. Let's proceed. So for example, this is an example given here. Note the following. Let's look at these notes. The zero matrix is the identity matrix in matrix under addition, right? So I explained this earlier that because the zero matrix has zeros everywhere, when we add it to anything, we get the same thing, and in the end, it becomes our identity matrix. Because when we have, let's say, A, B, C, D, right, plus our zero matrix, which is 0, 0, 0, 0. When we add, we are going to get A, B, C, D, because A plus 0 is A, B plus 0 is B, C plus 0 is C, and then D plus 0 is D. So that's why we say the 0 is identity in addition. So whenever you're adding, the 0 or null matrix is your identity matrix. Just look at the second one. The matrix addition is commutative and associative. Perfect. Matrix addition is commutative and associative. Commutative and associative. commutative property can be defined as this. What this means is, here if I add A to B, and then in the next example, or I also do the same thing by adding B to A, I get the same answers. That is the commutative property. So in matrix multiplication, in matrix addition, if I ask you to compute A plus B, and you intentionally or mistakenly compute B plus A, you have nothing to worry about, because matrix addition is commutative. So you can turn them anyhow and then still add and get the same answer. What's of the associative property? This is the definition for associative property. Right, so if I ask you to compute this, you could compute it this way first. So this is associative property. If A plus B, the sum of A plus B is added to C, right, we will get the same answer as adding the sum of B plus C to A, right? That is the associative property. So that is the associative property. Now let's move on straight to some examples. Let's move on to some examples. Example 1, right? So a shop holder has 2 separate shops which opens on Monday, Wednesday and Friday. In a particular week, she made the following sales in the two shops. Represent the sales made in the week in a matrix. So in this example, they just want you to represent the sales they made in a matrix, and that is very simple. You just draw your parentheses, then you take the elements from the table and then fill them inside. So we have 10, we have 8, 6, 8, 7, 9, 11, and 12. This is easy, very easy, right? Very easy. Then in the next shop, this is for shop A. This is shop A, sorry for bringing it there. And then for shop B, we have 9, 10, 8, 7, 9, 10, 13, 11, 15. This shop B. Yeah. I think down there we're asked to sum them up. So if they ask for total sales we made, right, it's easier to just sum A and B, total sales. So if I ask for total sales, because A represents the sales made in the first shop, B represents the sales made in the second shop. So if I want total sales, I can just add A and B, and in the end I'm getting 10 plus 9, 19, 18, 14, 15, 16, 19, 23, 24, 20, and then 27. Perfect. So this is the total sales made. Let's look at example 2. A matrix A and B are given below. Find A plus B. This is very simple. A plus B. So A here plus B here. You take the corresponding element, 2 plus 3, you write it there. 6 plus minus 5, you write it there. 4 plus this plus minus 7 here, and then 8 plus 9 is also here. You sum them up and you get the same thing here. Right, another example here, and we don't need to solve all that.